All right, Farmer Phil has 80 meters of chicken wire available for constructing a chicken enclosure against an existing stone wall. Phil wants the enclosure to be rectangular as shown in the diagram. Let the length of the enclosure be X meters. Okay, so there's our length right here. So I'm going to use W to represent the width. All right, show that the length of side AB is 40 minus 1/2 X. So when you see show that, that means how would you derive this expression here? All right, well, we use the fact that the perimeter is using up 80 meters of fence, but the perimeter is only made up of 3 sides. So if I take the length, which is X, and then I add the 2 widths, I should get 80. All right. So I want to show that side AB is equal to this. Well, side AB is W. So I'm going to take this equation and solve it for W. So I'm going to move the X over and I'll end up with 2W equals 180 minus X. And then I'm going to divide all the terms by 2. And I end up with W equals 40. X over 2 is the same as multiplying by a half, so that's the same as 1/2 X. There's my answer for it. Okay, part B says find the area of the enclosure in terms of X. So I'm going to write a formula for the area that only has X's in it. Right, so part B will be right here. All right, so I know that area is equal to the length times the width of a rectangle. All right, well, my length is X, so I can put A equals X, and in W, I'm going to put 40 minus 1/2 X. That's the width. Now I multiply that out, and I get 40X minus 1/2 X squared, and that's my there's your formula for the area in terms of the length. Okay, and now part C, sketch the graph of the function, find the maximum area and enclose it, or that Phil can enclose, and state the length, the width, and the area. All right, well, I know that this is going to be, I could graph it on my calculator. Okay, I know this is going to be a parabola that opens down. Now, in this formula here, A is your y-axis, and the X is going to be your X, or your horizontal axis. Not because it's the variable X, this is the independent variable. So the X represents the length, and the y-axis represents the area. Okay, this is in square meters. This is length in just meters. So we know that you can't have anything negative, can't have negative length, can't have negative area. So my parabola is going to look something like this. It's going to open down. And then here at the axis of symmetry, I'm going to have my vertex is going to, the x coordinate is going to tell me the length that creates the maximum area. Then once I get that, I'll take my length and I'll substitute it into this formula for W, and that'll give me my width. Okay, so for the last part, as I showed you in the previous slide, to get the length that creates the maximum area, I'm going to find the axis of symmetry. Okay, so the length would be, or the axis of symmetry would be the x coordinate of the vertex. So since this is in general form, the vertex is equal to the opposite of b divided by 2a. So I plug in negative 40 for the opposite of b, and then 2 times negative 1/2. Do the math, and I get the length is 40. So I know that this value right here is 40 meters. Okay. Then to get the width, I take that 40 and I'm going to substitute it into this equation here, evaluate it, and I get a width of 20. So then the last question, part of the question says, well, what's the area? Well, if I do 40 times 20, I'm going to get 800. Or if I took the 40 and I plugged it into my area formula right here, that's the same thing as getting the y coordinate of the vertex, which is 800. So this value right here is 800. And that would be square meters. And that's number 9.